You're gonna want to write this page number down. Because you're gonna want it for your homework. Page 254. Because this is on your homework, it will not be on your test. When you have two lines on the grid, how can there's three possibilities. What are the three possibilities you can have if you have two lines on the same grid? They can be like this, where they intersect. They can be like this, where they're, what are those two lines? Parallel. Yeah. Parallel. Or they can be like this. What's going on in that third one? Oh no, they're both there.
They're on the same line. No.
One line is on top of the other, i.e., they're the same line. I don't require this because, again, if you're going on to 109 or 111, you don't ever deal with this again. If you're going to 107, you might want to keep these notes. If they intersect, they call these, because you have one solution here, right? These are called consistent because they have a solution, and independent because the lines have nothing to do with each other except for the fact they cross. So visually, if this is one of my lines and this is the other line, I can move one of them and I still only have one intersection point, don't I? So that's why they're independent, because they can move, but they're consistent because they have one point where they cross. With parallel lines, what's the solution? There isn't one, is there? With parallel lines, they don't cross at all, so this is no solution at all. The two lines are completely different and don't ever get together. So these are called, then, if there's no solution, these are called inconsistent. And if they're inconsistent, there's no answer. Who cares if they're independent or dependent? Because they don't ever, yeah, I guess you could call them dependent, because if one moves, the other one has to move too for them to not have, to stay parallel. When one line is on top of the other, did they give a name for that? Oh, they call it coincident. Yeah, they're coincident line. I've also heard them called concurrent lines. Who cares what they're called? There's one line on top of the other line. So these, there is an answer. How many answers are there? Yeah. What color have I not used yet? There's infinitely many solutions. Now, they don't say all real numbers, because clearly this number out here ain't a solution. It's not on the line. So there's a billion non-solutions, but there's infinitely many solutions. So they will call this consistent because there is a solution, but if the two lines are on top of each other and one moves, what does the other one have to do? It has to move also for them to be the same line, right? So they're going to call these dependent. Again, I am not going to ask this on the test. It is on your homework. As far as I'm concerned, it's about useless. Because you're not going to use these vocabulary words again. So how are you going to know? Well, when you have one solution, it's just going to work out, right? Let's go back to that example we had a moment ago. What were those lines we gave you? Y is equal to 3x.
3x minus 2.
3x minus 2. And the other equation was
2x minus 3y.
2x minus 3y
Okay.
equals negative 8. When we did that, you had one solution, right? It was 2, 4. So this would be consistent and independent. What they'll do on the homework is they'll ask you, well, I'll pull one up here so you can see what it looks like. Week 7, I think it is. Yeah. The solution is blank. There's 2 parts. So if there is one solution, you would put it here. And then part B will say, is this consistent and independent? Is it inconsistent, or is it consistent and dependent? I'm going to change the green one just a bit. Oh, no, excuse me, this needs to be 9x, not. Okay, so what happens if it's one of the other ones? Well, if you plug this in, doing the substitution, we plug this in, I'm going to get what? 9x, 3. So then I'll get 9x minus 9x plus 6 equals negative 8. What's 9x minus 9x? Gone, isn't it? 6 equals negative 8. Is that possible? When does 6 equal negative 8? Not in this world. Not true, not possible, whatever you want to call it. What does this mean? No solution. These are, in fact, parallel lines. So this then would be answer C. There's no solution. Which means then that it is inconsistent. So if you're using substitution or elimination, and you get down and your X's and Y's are both gone and you have a false answer. Not possible. I like that even better. Then it's no solution. On your test, I will not ask you to do the inconsistent, but you will be required to tell me if there's no solution. So what happens if it's the third choice, if it's one on top of another? Well, it'll look something like this. So now when I plug it in, and again, you could use, we're running out of time, otherwise I'd show you what it looks like in elimination. When you plug it in again, don't get too restless yet, folks. And when this is going to be what? Negative 9x plus 6 equals 6. Six equals 6. Is that true?
Mm-hmm.
More than that, this is always true, isn't it? 6 is always equal to 6. What does that mean? Letter B. Infinitely many solutions, which then means it will be consistent and dependent. And again, I will not ask you the consistent dependent part, but if it's infinitely many solutions on your test, I will expect you to tell me infinitely many solutions. And yes, half of you on your test, one of the forms is going to be no solution. And the other form is going to be infinitely many solutions. Which one you're going to have? No idea till you get there. But do you see the difference when you are solving? If your X's and Y's both disappear, then you've got one of these two special cases. If your answer cannot happen, 6 is equal to negative 8, it's a no solution. If it is true, then it's infinitely many. So that was complication 1. We don't have time for